Okay, and today we're going to talk about angles. Angles are fairly straightforward. Most of this you'll be very familiar with already. There are a few new items in here, but most of this is just going to be a review of middle school math and geometry and some of the stuff you do with angles. First off, an angle is made up out of two rays. The two rays have the same endpoint. We call that common endpoint the vertex of the angle. The sides of the angles themselves are rays. They're not lines, they're not segments, but rays. They are infinite. The interior is the area between the two rays going the short way around. The exterior is going the long way. To measure an angle, we simply take our protractor, and by the way, we will not be doing a whole lot of measuring angles, so don't worry about it. If you need to borrow one in class, I certainly have some available. But to measure an angle, all we do is take the protractor, we line the center up along the vertex, and the zero goes along one side, and we measure off, and we read off the measurement. Now, again, we count up from 0, not down from 180, because there's two measurements on there. So always want to be careful to make sure we're using the right measurement. But here I start at 0, 10, 20, 30, 40, and it looks like about 3, so I'd say 43 degrees would be the measure of that angle. Pretty simple stuff. Identifying angles, again, we should know this pretty much intuitively. An obtuse angle is greater than 90 degrees but less than 180. An acute angle is a cute little angle, less than 90 but greater than 0 degrees. A right angle is exactly 90 degrees, and by the way, we often symbolize that with a little right angle box in there. If you see that box, that indicates that that is a right angle. And finally, this one's a little bit different that you may not be used to, but it's called a straight angle. It's also opposite rays, if you want to look at it that way. It's also a line. It's all the same thing. But we could refer to that as a straight angle. So if I say the points here are A, X, and Q, then AX, the angle QAX would be called a straight angle. Straight angles are a little obscure. We don't really use them very much, but they're out there. They exist, and you just do need to know about them. Couple very simple properties we're going to be dealing with angles. First off, angle addition. Basically, it's saying this. If I take this angle area measurement right here, and I take this angle measurement right here, and I add them together, I'm going to get the big angle measurement. Okay? A fairly obvious concept, but one that we do lay out in geometry formally to say that it is allowed, that we are allowed to do that because we are building a system of logic that requires rules. This is one of those rules called the angle addition postulate. So small angle plus small angle, you put them together, they have the same vertex, that equals a large angle. So if I'm given an algebra problem like this, and say 2x plus 10 and 4x minus 3, to measure those angles, and I'm told the large angle, ACM, is 140, then x equals what? Well, here's where it gets interesting. Here's where we have to start setting up and solving equations. And this is a very important part of geometry, something we'll be doing a lot of. And that is using a concept from geometry to set up and solve equations in algebra. And now there are a couple things we can do when we see equations like this and variables like this. There are a couple basic strategies we deal with. One is the two pieces have the same measurement. And if they have the same measurement, then we set those two variable expressions equal to each other. The other is the two variable expressions add up to equal some larger thing. In that case, we add the two variable expressions and set them equal to each other. Now, let's, in fact, back it up just a second. And let's say I just put some basic measurements in here. Let's say I said that this angle just temporarily was 59 degrees, and this angle was 63 degrees. I'm not saying that's what they are, but let's just say temporarily that they are. Then to find the larger angle, we'd have to take 59 plus 63. I think that idea is pretty straightforward. So here, if I want to set up and solve an equation with these angles, what I'm going to have to do is I'm going to say this angle, 2x plus 10, plus the other angle, 4x minus 3, equals the whole thing, which is 140. And now we have our equation. So figuring out how to set up that equation, I mean, it's not the most difficult thing on earth, but it takes thought. You can't just do the first thing that comes to mind. You have to look at the situation, analyze it, decide which equation is going to best describe what's going on, and then set up your equation. Then we actually have to solve it, combining like terms. 2x plus 4x is 6x. 10 minus 3 is plus 7. It's 140. We subtract the 7 from both sides. I get 6x is 133. And divide by 6. And I get x equals 133 sixths. Now, you're saying that's a terrible number, and I agree. It's not a nice number at all. But it is a solution. And we don't have to work with that number, really. We just have to identify what the value of x is here. Now, sometimes we may say substitute that back in and find the actual measure of the angle. Usually when we do that, you'll get a much nicer solution for x than something like 133 sixths. But that is the way that we set up and solve these problems. Here, I have angle MXG is what, according to this box? Well, with that box, that tells me it's a 90-degree angle. Measure of angle GXC is indicated as 28. What would be the measure of the larger outer angle, MXC? Well, 90 plus 28. Which is 118 degrees. Not a difficult concept. Congruence. Here we go. Two or more objects are congruent if they have the same measure. The symbol for congruence, given right there, is this equal sign with a little squiggle line over the top. That's a symbol for congruence. Now, congruence and equal are not the same thing. We'll talk about this a lot. Equal means they're exactly the same thing, using the same points in the same space. Congruent means they have equal measure. Really what it boils down to is numbers are equal. Equality applies to value in general. Congruence applies to things like angles or segments or triangles. So if I want to say two triangles have exactly the same measurements, I'd say they're congruent triangles. If I want to say two angles have exactly the same measure, I say they are congruent angles. They are not equal angles. Their measurements are equal, but the angles themselves are congruent. And that is a point we're going to keep working on, and we'll talk about as you're working through your assignments as well. Now, congruent angles have the same measure. We know that. One thing that is interesting also is the idea of an angle bisector. And again, let's look at this word. Bi, you write a bicycle, that's two wheels. Okay, bi means to cut two. Sector means to divide. So it's divided into two sectors and divided equally. An angle bisector, if we know a ray is an angle bisector, we know it's dividing the angle into two congruent parts. Now, back in these earlier examples, it may have kind of looked like maybe these two angles were the same, but we were not told that ray CR was an angle bisector, so we cannot assume it is. You have to be very careful about making assumptions in geometry. We didn't know if CR was dividing that angle equally or not, if that was an angle bisector. So since we don't know that, we can't assume that it does. However, if we are told that something is an angle bisector, now that opens a whole new world of opportunity for us. Because that's going to change the way we look at our equations. Here I am told that AX, ray AX, bisects angle WAY. By the way, angle bisectors are always rays. So now, my whole algebra thought pattern changes because we know it's a bisector. I'm not going to add these two together and set them equal to a total. Since this is a bisector, it means these two angles are congruent to each other. And yes, these little single arcs indicate that congruence. visually for us. So I'm going to take these two algebra expressions and I'm going to set them equal to each other and solve the equation. Doing my algebra work, 2x's cancel out, I get 12 equals 2x over here, so x is 6. And I found the value of x. I could then find the measures of the angles and check to make sure that's true. That's 2 times 6 is 12, plus 10 is 22. 4 times 6 is 24, minus 2 is 22. Each angle is 22 degrees. The whole thing would be 44. Now, not drawn to scale, obviously, in this case, but that is the way that it works out. That's the way the numbers work out in this case. But it really illustrates why we have to always stop and think before we set up an equation. Because this picture looks almost identical to that other picture we had before. But the way we set up the equation was completely different because of the facts we are given about what's in that picture. So make sure before you set up an equation of any sort that you're always analyzing what are the facts before you set up and try to solve the equation. Our daily check. Answer this question in your notes. What is your angle? If you were an angle, what kind of angle would you be? And tell me why. This is kind of a fun question. Nothing really serious geometry-wise, just a fun little check. All right, that's all for today.